Hello guys, in this episode I will demonstrate the wheel cutting operations with tool changing and the auto touch pop of this workpiece first to get this surface reset positions, reset values, and also the center of this workpiece values. And you can see my previous videos in the YouTubes that mentions all the preparation words and explanations in order to do such things, and I briefly remind some things first. Firstly, the machines need to be homeless, and if it's the first time installations, that the toolbox must be properly position located, and I needed to find the circle center of this hole or this spot. This is a reference spot for touch pop reference, and I mounted a steel dial indicator here in the spindle, and by positioning it welded, this dial indicator pointers will read the same at 4 directions. And of course, at the back, I use a small mirror. You see, it's difficult to see. It's almost zero. A little bit, just a little bit off, just a little bit off the 14 reading. And I put this XY values on this 2DL box to finish the circle finding, and this position readings will relative to the home positions. And in this automatic machinings, I also incorporated the coolant or mist cooling. This is the mist or liquid, this is the air. And in the original control box, it only included the fat cooling. There's a AC socket here. This is AC socket for the spindle, and on the here, this is AC socket for the coolant. So I can use M3, M5, I don't remember, M5 to operate this AC socket should be on to water to the liquid pump. Instead, I use the mist coolant, so I need to operate the air. I installed the air valve, electrical air valve here. It's difficult to be seen here. It's 24 volt, and so when M-code is operated, this air valve to be on or off. So we'll turn on the mist coolant. And here is the workpiece for machining. It's here. I will enlarge the center hole as well as the 4 holes on the corners by 1 millimeter in diameter. And since this is already recessed, I need to pop this surface center, so I put a little piece aluminum sheets here so they the same level for touch pop here to get the surface values. And it's 2 machining operations. The first is the center large hole. It will use a largest M4 sorry, it should be this M4. This M4 we turn on, and then the 4 corner circles I will use M3 diameter M mills to do. And I need to install properly 3 tools on the pockets. One is the touch pop here. I explained this in previous video. Another tools, one is M4, here is M3 milling cutter, and here is the G-code file for the cutting operation, and here the 3 M6 first M6 T6, refer to this M6 T6 to number 6 is for picking the touch pop for calibration first, 1 and 2, and number 8 is here, is for picking the pop for regular popping operation. That's after finish the calibration, the 4 sides, the center hole for verifications. The touch pop will come here and do the regular poppings, this surface, and then 4 sides. Then it changes the T number 2. T number 2 is here. We will call this for change 2. It's not very clear sometimes. Computer. And of course it will do the tool setter for the tool length compensation, and here do the offset tool length compensation. And stroke down here, it will end this the first operation and change to T number 3 and do the same until finally it go down to here, finish, and then do extra operation T0, M6 T0. This will bring the tools back to the empty pocket, and then finish all the stuff. So you can see here M5 and M9 is to stop the spindle and the mist coolant, and here M3 do the start spindle and turn on the mist coolant or air. It start up, this LED lamp turn on when T-code program runs. And it begins to do I need further to do the calibrations for finding the circle center. We will make use of this over truffle data and enter to the measure circle center DRO values and see if they are matched with this. This is the true center value. And you can see here the differences 0.04 and 0.02. So this verifies the circles. It means the measure circle center is the same as the aqueous input one. So these four values are confident, and we will continue to the next operations. There's T number 8. There's the using these touch probes to touch the workpiece to get the positions value. of the center positions. I can enter the 0 here first. So the values appear, and also the center is set as origin. And now it will change the tools to number 2. Going to cut it. Going to change to number 2. There's 3mm cutter. 3 we do 2 compensation. We return the tools to the empty port pad. Here's the T number 0. And complete the operation. Now we take it out to check the dimension. And here, this is the X+ direction. Is 0.0 something. It's difficult to 0.02. This is 0.03. It's more close. 0.03 or something. And here 2. 2 to 2 3, and here 2 5, and here 2 3 2 4, here 2 5. So in x direction is already around 0.02 or 3 deviation. Now this is y direction. Since this is not a true rectangular, true square, there is some deviation here originally. It's difficult to measure. So anyway, I just compare the plus and minus direction. So here is y direction. Point 1. So something 0 3. It's 9 or something. 9 8. 9 7. Is around 0.1, 0.01, 0.01 to 0.03. Is 99 or 0. Anyway, here 2 3. Here is 2 1, 1 5, 1 4, 1 6, 2 0, 1 9. Sorry, this is 2 4, 2 3, 1 9. This is 1 8. So here check again. Zero 2 or 0 3, 0 1. Zero 9 9 9 8. This 0 1. 2 0. 1 8. 1 9. 1 9. Almost 1 9. So it's also around 0.03 maximum deviation in y directions. In x direction, zero 1, 05, 02, 21, 24, 23, 23, 22. So it's quite centering on the workpiece, and I accept the process. I will continue to do another measurement checkings of this center and also the four corner XY positions value. The workpiece outer shape, and I will do the first is touch this one, touch the workpiece top surface, and I have already included all the required manual input value there. This mark, you see, number 8. This is the thicknesses of workpiece with the parallel bar, length and width. Gauge thicknesses is not applicable. 9 and 10 is those are measured the measurement values that's going to be happen. So this center of the Y's, and number 5 is hit this from bottom, inside bottom of the Y's to the top of the bottom of the touch pop ball. So I'm ready for the measurement. Click this regular touch popping, and I will go to this page, enter to select pop 0, already in spindle. Yes, otherwise it will go to get the rectangular outer. 1 is already done. Actually, I need to quickly this auto popping workpiece is set on Y's. There's touch here. We will change this value 9 and 10. Number 9, 10 here, number 9 here, the top of, yes, this already changed. And ask me to make decisions. And next process, I will touch 4 side to get the center position. So okay, continue and quickly go to touch pop page. Okay, so again here, and workpiece center on Y's, workpiece XY coordinate position. And after taking measurements, the coordinate data will enter this box. To override the previous value here. He asked me if if I continue and use new derivations value. This on the next page. I have the 4 derivations value. Number 1, I choose to use, and after OK, this value will be changed. There's the center position. Input for selections. I will choose 0, no change. If I continues to change the cutting tools to machine the workpiece, I will use this center as origins, and I will keep this number 1 for setting XDRO to 0. Now I don't do this, and I choose 0, no change. He asked me again for Y coordinate, also no change. So this is the center. I will write down on this sheet, on this paper. Now in next operations, I will make measurements on this corner, lower left, this one, and I will use these features to get the current DRO to enter this box, approximate corner X, approximate corner Y. So in order the auto touch popping can be carried out, these features, if I have mentioned this in the previous videos on YouTube, and you can take all the explanations of this touch pop operations there. And now first is I need to move the spindle or touch pop roughly above the corner. And here is the approximate DRO X and Y DRO coordinate. I will hit this one to copy this value into this box. First I need to clear the old value 0 and hit again. Then this value will be entered here, and in the programs I can make use of it. Now turn to this page. I will choose this box and also this box. Take measurements of workpiece XY coordinate. Now move this and click this regular touch popping and go to this page 0. And here, and choose this ready. and it will input this box. Inputs for selections, as well as I will choose 0, no change on current DRO. Zero. Sorry, actually it is here. Here. Actually here. I make confusion. The corner XY coordinate is here. I copy this value to this paper. Now I continue to make measurements of this lower left, this one, sorry, upper left, this one, and this one. So I move the touch port roughly above the corner and get the current position. Zero. And I will start the measurement here, here, enter. One already prepared. And again, it will override these period O values here. Zero. Zero. So I copy this value to my paper. This is upper left here. Here, the final corner. So all done. And the test finish, and I've done 4 times for each of the corners, and here is the 4th time step. In calibrations, there is very small amounts of deviation here, and all the data is recorded here. And this is the center, and this is the X direction. The length, half of the length is this, the width, half the width is this, and the corner, the lower left, upper right, lower right. I start here and here 1 times, 2nd time, 3rd time, and 4th times, and the corner values record here, and the center values recorded here. So let me take a look at the 3rd times. I pick up the center positions, the X, this one, and then do the subtraction and the plus additions of this half length of this value. So this is X values, and compare this value with the measured corner. So I compare the X minus value here, 200 something, with the deviation here by 0.09 for this. This deviation is 0.13, so it's more than 0.1. Is no tick here. So the another X value, the X plus value is 157. With this value is only 0.04 deviation here. This one have only 0.07, so I give it tick. For the Y directions, so I pick up the 3rd one, this one, 74, and the half width is this, and come out 2 values, and this is the minus Y value, and number 3rd, this one and this one. So here it has 0.04 deviation, and this one, the 3rd one, and this one 0.01 deviation, so it gives it a tick. For the Y values in minus direction, this one, number 3, this one, this one, and this one, 176. This has 0.04 deviation, and here this one 0.02 deviation, so I give it a tick. The best result is number 3 and number 4 one have only 2 ticks, and number 2 have 2 ticks here. The first one only 1 tick. So these are all the measurements, and you can see one more thing from these figures. For the same times of measurements, you can see the number 4, you can see 2 value very close. These 2 value 1 4 not this one, and this one, and this one 176. Sorry, the first one is the poor. I don't know most of the matter. Let me take a look at number 4. Number 4, this one 17, and see this 17, also number 4. So the value very close, and the x sorry, and this x is very close, and also this y also very close. So go to number the third times. The third time is here 133.32, and this 0.35 very close, and 200.x4.88 very close, and this also the first time measurement 0.72.80. So in the same times measurements, the touch probe do very decided measurements, but some is not very not very good. I think is due to the machines and not due to the test program or the touch probe. I think I have used these machines for about 12 years, so the lead screw nuts are not very good manner. Maybe some backlash will affect the results, and later on I will implement the touch probe operation in this my builder's largest machine to use a better components. To use the THK ball screw, linear actuator, and also NSK ball screw linear actuator. Actually, I have incorporated tool change there, and here is the tool setter with the air blast coming out when tool is measured, tool length is measured, and there is a toolbox at the rear it will go forwards to this spindle positions to have the two changes. And here is the back of the machine, and this is the two boxes. Have 1, 2, 3, 4, 7 tools installed here. It uses ER20 collar. And later on I will have the demonstration of tool changes, and I think the implementations of the touch bob operation is very complicated because these machines run in Linux CNCs, and I've learned it for quite a long time, and finally I have already done this the tool changing programs, but the programming methods or language is much different from Mark 3. Mark 3 is very friendly. Is a friendly use programs. It's very quick, and if someone's have experiences in programming in C language, it will easily do the job, and also it have a lot of tools to be used to make the interface and the programs. However, the Linux CNC is not so good in this aspect. And thank you for your watching this video.